Hello viewers. In this video, we are going to learn how much transmit power is required for a fiber optic system. Let's start with an example. Here we have two cities, city A and city B. We have a fiber cable run between city A and B. The length of the fiber cable is 80 kilometer. So we are going to find out how much transmission power is required for this particular example. Okay, before starting to calculate the transmit power, we have to study five different parameters. The first one is the fiber loss coefficient. For example, I am transmitting 10 dB transmit power, and then while receiving it, we got only 2 dBm. So we are losing power while traveling in the fiber optic network. So how to calculate this power loss while traveling in the fiber optic network? This is given by the vendor itself, and it is depends upon the type of the fiber. For example, it is a single mode fiber, then the loss will be 0. dB per kilometer. That means for every kilometer the light travels, it loses 0.25 dB of power. Now, okay, for this example, it is 80 into 0.25, so it is losing 20 dB while traveling in the fiber optic network system. The second parameter is the spice loss. Okay, so we all know that we can't able to run a single fiber cable from city A to city B. That means we don't have a fiber drum of 80 kilometers. Usually a fiber drum comes in 10 kilometer length of fiber, or sometimes it is 4 kilometer length of fiber. For in this case, we are considering a drum of 10 kilometer. It means this drum consists of a continuous fiber of length 10 kilometers. So obviously, how much drums is required for 80 kilometers? It is eight drums is required. So how we are going to connect all these different drums? We need to do the splicing, that is called as arc splicing. So whenever you are doing splicing, we are going to lose power. For example, each splice you are doing it, for example, consider this case, we are losing 0.1 dB. We can improve it. How can we measure this splice loss? We can do it in the splicing machine itself. We can measure it in the, okay, now in this case, for example, 0.1 dB per splice. So there are 8 splices have been done so that we can get an entire stretch of 80 kilometer fiber. So in due to spice loss, we are 8 into 0.1, 0.8 dB powers, we are losing it for spice loss. Then the third parameter is maintenance loss. Of course, we may expect fiber cuts in the future between these two cities. In our example, we will consider two fiber cuts. Okay, so in each fiber cut, we have to do the splicing. Again, there will be a splice loss. This time it will be bit higher than the earlier one. For example, we consider 0.5 dB per splice. Again, we can measure it while doing the splicing, or else we can run the OTDR in the fiber and it will calculate the losses in every splice points over a distance. We can't connect the OTDR into the live fiber. Instead, we can connect it into the dark fiber in the same cable. And the fourth parameter is the receiver sensitivity. What is receiver sensitivity? It is the minimum power received by the receiver so that it can able to decode the baseband signals from the transmitted signal. So, again, this is given by the vendor. For example, I'm transmitting 10 dB power, but in the receiving side, I'm getting 2 dB, 2 dBm power only. But the receiver can't able to decode the message from this transmitted power, from the receiving signal, because it is contains very less power. So it requires minimum amount of power so that it can able to extract all the messages from the incoming signal. So this is given by the vendor itself. For example, minus 25 dBm. Even though it is given by the vendor, it is depends upon a lot of parameters. We have taken 7 such important parameters. So one is the detector material, the receiver materials for what type of receiver we are using it. There are three, four materials out there, and the bit rate 200 Gbps, 100 Gbps, and what is the bit error rate criteria, 10 power minus 3 or 10 power minus 6, and different wavelength react differently, and temperature plays a crucial role. And the circuits in the receiver, like transmitter, amplifier, all those things also play a crucial part in that. And of course, the last one is the signal to noise ratio. If you have a good SNR ratio, that means it is a good system, immune to noise. So all these factors plays a crucial role in determining the receiver sensitivity. Okay, let's move on to the final calculation. So now we are going to calculate the minimum transmitter power required. So what we are doing, whatever parameters we have studied, we are just summing up all those things. So receiver sensitivity, fiber loss, splice loss, maintenance loss, all these things we have seen, but we didn't see the maintenance margin. So the planner said it is always a good practice to give certain amount of maintenance margin, say for example 5 dBm in our case. Here it is mentioned. Okay, so what it means in future, due to fiber aging and future fiber cuts, in order to accommodate these future losses, we include certain value in the calculation. So that is called as maintenance margin. This is called 5 dBm. Okay, if you carefully look at the formula, you can see I am adding here dBm and dB. You can ask me a question. How come you can add dBm and dB? Both are in different units. So the answer for it, that is covered in a different video. What is dB and what is dBm? How can we able to add these two power levels? Okay, I will give the link in the description part. Okay, once we sum up all those things, we will get the minimum transmitter power. Remember, it is a minimum transmitter power. Okay, then we will come back to optical power budget. We often heard this term optical power budget. It is nothing but the difference between the transmitter power and receiver sensitivity. We know receiver sensitivity, we know the value of transmitter power. Okay, what optical power budget means? It means the allowable power between the transmitter and receiver. I'm sorry, it's a allowable loss between the transmitter and receiver. If your optical power budget is very good, it means it can accommodate more losses in your system. Okay, that's the meaning of it. For our case, we are going to calculate the optical power budget. So it is transmitter power, it is 2.3 dBm, and the receiver sensitivity we know that it is given by the vendor. So this is the optical power budget for our example. So from this value, we are come to three different conclusions. One is it is not recommended to keep it exactly the 30.3 dBm. Why? Because in future, many things happen to the fiber network. So lot of fiber cuts, aging, all those things. So in order to accommodate these things, if you can able to increase the power budget, power budget. If you want to increase the optical power budget, what is the option available for us? The only option is increase the transmitter power. So if you increase the transmitter power, if your optical power budget will increase, it means your network is susceptible for the future losses of the system. Okay, so and the third part is remember if you pump more transmit power, it means sometimes it is too good for the receiver and it may damage the receiver as well. So you have to carefully play with these three values. You should satisfy the receiver sensitivity at the same time. You should not go beyond the threshold limit of the receivers because it may damage the receiver. Okay, this calculation is for the system without any optical amplifier. For example, in our system, we have an optical amplifier in between city A and city B. In that case, how to calculate it? Slightly change the formula. We introduced two concepts. Since we have introduced the amplifier, it has a gain, so we are subtracting the gain in the formula. Of course, since it is a device, electronic device, it has a noise figure. So find out the noise figure for the amplifier and add it to the total loss. So that's it. So if you do all those things, we can get the same value, and the derivations are same for that one. So remember, optical amplifier is nothing but it just amplify the signals in optically. It's not doesn't convert optical to electrical and electrical to optical. Okay, that's all, viewers. The document for this presentation or the lecture is given below in the description. You can visit that website and find out. If you have any questions, please type it on the comment section. Thank you for watching.